We have so far talked about trig only in the context of a right triangle. So the reason why we've done that is we use this phrase SOHCAHTOA, and we talked about opposites, adjacents, and a hypotenuse. And a hypotenuse only exists in a right triangle. So we've only been working with right triangles. That's pretty limiting, though, because not all triangles are right triangles. So in these next two lessons, we're going to look at how can we do trig if we don't have a right triangle. And the first thing that we can do is called the law of sines. To be able to evaluate and find the parts of a triangle, you will need to know three pieces of information about that triangle, some combination of sides and angles. It will work to know certain sides or angles. It will work to know all of the sides, but it will not ever work to know all of the angles, because you can have like a little tiny triangle that has all 60-degree angles, or you can have a huge triangle that has all 60-degree angles. So just knowing angles will never be enough information for us, but as long as we know at least one side and then three pieces of information total, we'll be able to find out what all the other missing pieces are using some different trig methods. For some of these setups, we'll be able to do our law of sines today. For some of them, we'll need to use something called the law of cosines, which we'll be talking about tomorrow. So the law of sines is a proportion, or a set of fractions or ratios, where we set up the sine of an angle with its matching side. So when we name a triangle, we name angles with capital letters. Capital A, B, and C represent the angles. We name the sides with lowercase letters, so the little a, b, and c are the sides, and we name those across from their angle. So opposite of angle A is little side A. Opposite or across from big angle B is little side B, and opposite or across from big angle C is little side C. Okay. Some books or people or wherever you would learn this set up their ratios upside down so that all of their sides are on the top and the signs are on the bottom. It doesn't matter. It is exactly the same formula either way. When we learned about ratios and proportions back in chapter 7, we learned that you can flip them upside down and it still works. So this is the way I do it out of habit, is I set up my sign stuff on the top and my sides on the bottom. You always set up a matching set though, so the angle goes on the top and the side goes on the bottom, but using the same letter. So A over A, B over B, C over C. You do not need to memorize this formula, but I would bet you'll have it memorized by the time you finish your homework, because there's just not that much to it. We're just matching up the letters. But it will be printed on the quiz to kind of jog your memory if you get stuck on it. So to use it, you will be given three pieces of information about a triangle and then asked to solve the triangle. That means find out everything we don't know about it. So find out the other three pieces of information. There are 6 things to know about a triangle, 3 angles and 3 sides. So I begin every problem by making a chart that shows the 3 angles and the 3 sides. And then I fill in what I know. So I know angle C is 103. I know angle B is 28. And I know side B is 26. So those are my 3 given pieces of information. I need to solve for the other 3 pieces of information that we don't know yet. To use the law of sines, you must always know an angle and a side, okay, that match. So we need to know both parts of one letter. If you know 2 angles and you are missing one side, we can find that first with no trigonometry. What do we know about the 3 angles of a triangle? They should all add up to 180. So we can see what's left over from the 180 to find that missing angle. So whenever you know 2 angles, the first thing you can do is subtract to find out what the missing angle is. And it's 49. It's frozen, but it's 49. Then we need to start solving for sides. And for solving for sides, we need some trig now. What we're going to do is pick the pair of letters that we know both parts of. So that would be letter B. And we're going to set up sine of the angle over the length of the side. So sine of 28 over 26. And it froze again. Then for our second fraction, we're going to use another piece of information. It does not matter whether we solve for A or C first, because we're going to have to do them both. So I'll just go ahead and go alphabetically and solve for A. So I'm going to then say sine of 49 over little a. So in each fraction, we should be matching a letter. So in the first fraction, I used both parts of letter B. And then in the second one, I'm using both parts of letter A. But I don't know little a, so that's the variable in the problem. How did we solve a proportion? Cross multiply. So we're going to multiply this thing on its diagonals, and that gives a sine 28 equals 26 sine 49. And we multiply on the diagonals or cross multiply to solve a proportion. Now we're trying to solve for a, so we need a to be all alone, and right now it is not all alone. It's with that sine of 28. So we are going to divide by sine of 28 to get that a alone. So this is going to give us our answer for A. And we can type that in our calculator. If you're working with a graphing calculator or scientific calculator, you can type it directly straight into your calculator exactly like it says. The one thing we need to be very careful about is when you press a trig button on your calculator like sine, it automatically opens up a set of parentheses. So when you press the sine button, it doesn't just say sine, it says sine parentheses. You need to make sure you close the parentheses after you type in the angle. So you gotta, after that 49, hit the close, and then same thing after the 28, hit the close. And that should give us our answer.
Say it one more time. Close when?
After the angle. So after 49, we would want to close, and then after 28, we'd want to close. So we get about 41.8 or 42. If you are working on an I product, this is possible but annoying. Typing it in on an I product, you have to type everything in backwards. So you would have to do 49 sine times 26 divided by 28 sine, enter. So you can do it, it's just annoying because you have to type everything in backwards. This is a much easier process if you're using an actual calculator, a scientific or a graphing calculator. Possible on iProducts, but annoying to type everything in backwards. If you're doing it on a regular graphing calculator, scientific calculator, you just type it in exactly like it says. 26, sine button, 49, close off the parentheses to say that's the end of our angle. Divide by sine button, 28, close off the parentheses to say that's the end of our angle. We have one more piece of information we need to solve for. We still need to know what side C is. We're going to solve for side C exactly the same way we solve for side A. I always go back to the original given pair of information if possible, instead of using information that I found that could be wrong, because then if I build on it, everything after that will be wrong. So I'm going to go back to the letter B, where I knew both from the beginning of the problem, and say sine of 28 over 26 equals this time sine of 103 over C. In a fraction, you're always using the same letter on top and bottom, sine of the angle over the side. And we solve by cross multiplying, so we multiply those diagonals, gives C sine 28 equals 26 sine 103. And we're trying to get the C alone, so we need to divide by the sine 28 to cancel it out so this is all by itself. And we type that into the calculator. And we get about 54. 53.96, and we'll just call that 54. There's no quick way to check your answers and guarantee that they're right, but there is one quick thing you can do that sometimes raises a red flag. When we learned about triangles, what did we learn about the size of angles and sides?
The biggest angle is
The biggest angle should be opposite of the biggest side, and vice versa, the smallest should be opposite of the smallest side. So one thing I always double check once I'm done with a problem is I make sure that my biggest angle matches my biggest side, and my smallest angle matches my smallest side. That does not guarantee that your answers are right. But if that doesn't work, if your biggest angle is not with your biggest side, your answer is definitely wrong. Okay? So by doing that check, it doesn't guarantee your answer is right, but it will tell you for sure when your answer is wrong. Okay? We're going to do one more example exactly like this one. So when starting a problem, I create my chart of my 3 angles and 3 sides, fill in the ones that are given. I don't know why it's freezing so much today. So we know angle B is 118, angle C is 36, and side C is 14. When you know 2 angles, you can start by finding the third angle. We know the 3 angles of a triangle should add up to 180, so we can subtract out what we've used up so far to see how much we have left over for that missing angle. And we find angle A is 26. Then to solve for sides, we need to use our law of sines. I'm going to use letter C since I know both parts there, and say sine of 36 over 14 equals, and then it doesn't matter whether you go for A or B first because you have to do them both, and they don't build off of each other in any way. So I'll just go alphabetically and do sine of 26 over little a. Cross multiply. A sine 36 equals 14 sine 26. And we're trying to get A alone, so we're going to divide by the sine of 36 that is with it to cancel it out and get the A all alone. Then we type that whole thing into the calculator. Make sure you close the parentheses after you type in an angle. And we get about 10.4. Then to solve for side B, we repeat the exact same process. So I'm going to go back to using sine of 36 over 14, both of the given informations, just in case I've gotten something wrong so far. I don't want to build off of it if I don't have to. And then I'm going to do sine of 118 over little b. Cross multiply. B sine 36 is 14 sine 118. And divide by sine of 36 to get the b all alone. And we get about 21. Our quick double check is just to make sure that the biggest angle B matches the biggest side B, and the smallest angle A matches the smallest side A. Doesn't guarantee they're right, but if that doesn't match up, your answer is definitely wrong. Okay. Questions on this type of problem? Okay, in our next problem, we're going to be given two sides and an angle, and this is called our ambiguous case. Back when we talked about triangle congruences, like side, 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 and side, angle, side, we said that side, side, angle does not actually work. And the reason why it doesn't work is when we would hinge this open, it could actually create two different triangles based on what that third side would be. I have a picture of how that would look. Is let's say I know how long these two sides are, those are given and they're not changing, and I know how big this angle is and that's given and not changing. I could take a third side and kind of swing it out this way or swing it in this way, and it's the same, but that actually makes two different triangles. Okay, I've got the one bigger triangle and then the one that's just kind of like a little sliver. So by swinging that third side in, it could actually create two different triangles with the same given information. So what that means is sometimes when given this type of information, you could end up with two different possible answers. I am only in this class going to give you problems that are set up to get one answer. Okay? In a later math class, you'll explore the possibilities of how this can occur with having maybe two different triangles, or actually it's even possible that you wouldn't have any triangles, that it actually isn't enough to even close up and make a triangle at all, or maybe it makes one perfect triangle, or maybe you end up with two triangles. But for our purposes, we are only going to work with problems that are set up to just get one possible answer. Okay, just want to introduce that this is kind of a strange thing that can happen in these types of problems. I don't have room to do the work here, so I'm just going to erase the problem and go to a whiteboard. We're going to set it up the same way. All of our solving a triangle problems, we're going to set up the same way by making our chart of given information. So in this one, we were given angle C is 122, little a is 12, and little c was 18. We do not know two angles, so we can't subtract from 180 to find a third angle. So we have to begin this problem with the law of sines. We do know both parts of one letter, so the law of sines is an appropriate thing to do. If you don't know both parts of one letter, then we would need our law of cosines, and we're not learning that till tomorrow. So that means in all of your problems today, you should be given enough information to have both parts of one letter. So we're going to have sine of 122 over 18. Matching letter C, angle on top, side on bottom. The only other thing I know is that little a is 12. That's a side, so it's supposed to go on the bottom of a fraction. On the top of our fraction is supposed to go our angles, but not just the angle, the sine of the angle. So on the top of that fraction, I need the sine of big A. We could solve this problem by cross-multiplying, but it is actually faster when solving for an angle here to just multiply both sides by 12. That will cancel out the bottom right away. Cross-multiplying will work, so if you're the kind of person that I just want to do the same thing every time and have one way to solve every problem, you can cross-multiply this. It'll just take 2 steps of work. If you multiply just by 12, it's done in 1 step of work.
You have to multiply 18 by 12?
No. If we multiplied both top and bottom by 12, that'd really just be multiplying by 1. So we're just going to multiply the top of that fraction by 12. And we type that in on the calculator, 12 sine 122, and make sure you close your parentheses, divided by 18. And that gives me a decimal, which doesn't seem like a likely answer, and that's because it's not my answer yet. That doesn't equal A, that equals the sine of A. We've already done some trig in solving for sides and angles, and what did we need to do on our calculator when we were solving for an angle? Second. So to find what our angle is on our calculator, we're now going to need to do the second sign of that answer that we got there. When solving for an angle, you have to do a second sign. And so that gives us about 34.4 degrees. Or we'll just call it 34. Okay, when solving for an angle, you have to do a second on the calculator. So we can type in that whole division, the 12 sine 122 divided by 18, but that is not our final answer yet. We have to do the inverse sine or the second sine when solving for an angle. And that will give us our answer of about 34. Now we know two angles. So when we know two angles, we can find the third angle by subtracting out from 180. So we can take what we've used up so far and see what's left over of the 180 for the missing angle. And that's 24. And then to solve for our last piece of information, we're going to set up another law of sines. I'm going to go back to the pair of c since that was given and I knew both parts there. Sine 122 over 18. And then sine 24 over little b. And now this is exactly like our first type of problem where we're solving for a side. When we're solving for a side, we need to cross multiply. And divide by what's with our variable, in this case sine 122, to get that variable alone. I'm going to get about 8.6. So then the quick double check, just make sure that your biggest angle C matches your biggest side C, smallest angle was B, smallest side was B. Doesn't mean our answer is definitely right, but it's a good idea to double check that. Questions? We're going to do one more of this type of example where we have to solve for an angle. So I'm going to begin by setting up my chart of given information and what I need to find. So in this problem, once again, I only have one angle, so I can't start by subtracting from 180. So I have to start with the law of sines. So I'm going to set up where I know both letters, sine of 96 over 19. The only other thing I know is 17, and that's a side, so it goes on the bottom. On the top, then goes sine of the angle that matches with that 17, so sine of A. When solving for an angle, you could cross multiply, but it is faster to just multiply both sides by that denominator of 17. We can type 17 sine 96 divided by 19 in the calculator. We get about 0.8898. Do not round this decimal very much. Keep it at least 3 or 4 decimal places. If you start to round that off, it will greatly change your answer. Okay, a little change in this decimal once we do the second sign on it can really change your answer. So keep that decimal out to at least 3 or 4 places. And then do the second sign or the inverse sign of that answer to get your angle, which is going to be about 63. Okay, 62.8 is what I got, and I'll just make that 63. Once I know two angles, I can subtract out what I've used up from the 180 to see how much is left over for the third angle. And that is 21 degrees left over. And then to solve for our last piece of information, we need one more law of sines. I'm going to go back to the letter C pair and then do the letter B pair. When solving for a side, cross multiply. So B sine 96 equals 19 sine 21. And divide by what is with your variable. So then on the calculator, 19 sine 21 divided by sine 96 gives about 6.8 for the third side of this triangle. Again, our quick double check works out. C is the biggest for both and B is the smallest for both. Questions on law of sines? We have one more type of problem to look at, but it is much quicker than these problems. These problems are long and tedious problems. I know. We've only done 4 problems. It's taken like the whole class period. There's a lot involved in solving these problems, and I know that, and it's annoying. Believe me when I say I'm not like holding out on you. There's not like a shortcut that I'm making you do it the long way, and then tomorrow I'm going to be like, haha, guess what? Here you go. There's not a shortcut to this. Sometimes there is, and math teachers do kind of hold out and make you do something the hard way first. There's not an easier way about this. This is just kind of as annoying as the process is. So I know that they're kind of long and tedious problems and involves problems. Thankfully, our last type of problem here is a pretty quick thing. The area of a triangle formula that most students learn at some point in a math class is area is 1/2 base times height. Okay? That works great if we know a base and a height. And if we don't, it doesn't really work because those are the things that you need for that formula. So this formula that uses trig allows us to find the area of a triangle when we don't know its base and its height. All 3 of these formulas are really the same. Okay? They each use each letter once. So whatever the big letter is, it's the other 2 little letters that have to be in there. Okay? You do not need to memorize this. The formula will be printed on the quiz. But again, I'm not going to print all 3, so you just need to understand that you can shuffle around the letters, just making sure that you use each letter once. Whatever big letter is the angle, you need to use the other sides. So in this picture, I couldn't use my 1/2 base times height formula because the height of this triangle, I don't know what it is. Right? The height should be a straight up and down thing. So I know the base is 5, but I don't know the height. 3 isn't the height. So we're going to use this trig formula instead. In general, what that trig formula says is 1/2 side times sine of angle between them. You have to have a side angle side to use this formula. You have to have 2 sides in the angle that's between them to use this formula. So we're going to do 1/2 3 times 5 times sine of 55. We just type that right in the calculator. And we get about 6.1 as the area of this triangle. Okay. So you don't have to memorize that formula. It's the same no matter what letters you know, just making sure that you know 2 sides in the angle between, or that you know one thing about each letter. For our last example here, again, we have a side angle side, so we can use this formula. 1/2 7 times 10 times sine of 36. It doesn't matter whether you do the 7 or the 10 first, because either way, they multiply to make 70. So it doesn't matter what order you pick those. We just want to do 1/2 one side times the other side times the sine of the angle that connects them. And I get about 20.6.
The 10 was like over by the BC.
Couldn't do it. We would need a different formula. You have to have side angle side for this formula to work.
So are all the problems going to?
Yep. All the problems I'll give you will have a side angle side. I'm not going to trick you on that. All right, so your homework is a worksheet in your packet. There are 10 questions. The first 7 are the solving the triangle questions. So they're like our first 4 examples. The last 3 are finding the area. So they're like these examples. Do not do your homework right on that sheet because then you'll rip it out and go to hand it in and then you won't have your notes for tomorrow that are on the back of that sheet. So you still need to do your homework on a separate sheet of paper, but you don't have to bring your book home.